Good morning students. J&K Kakinada Engineering Physics 4th unit Quantum Mechanics chapter lo nunchi I want to explain. First of all, let me explain what is meant by particle and its characteristics, wave and its characteristics. For example, the concept of a particle is very easy to understand because it is a physical quantity and physically it can able to see. Suppose any force is applied on a particle. Suppose this is a particle. On this particle, if some force F is applied on this particle can able to move in the direction of the force applied. And one important thing is, let me explain about the characteristics of the particle. Suppose here it is a particle. This particle has its mass, definite mass. It can able to move in a direction with a velocity. It has one more characteristics, that is nothing but velocity, and there is momentum P and energy E. These are the characteristics of a particle. So mass, velocity, momentum and energy are the characteristics of a particle. But it is very difficult to understand the concept of a wave because it is not a physical quantity and we cannot able to see physically about the wave. And a wave can be simply defined as, that is, the physical disturbance in a medium, and the disturbance may not be specified to one particular direction. The disturbance may be in all directions, and the characteristics of the wave can be explained as, the first one is wavelength, that is represented with the letter lambda, frequency mu, wave velocity omega, amplitude A, phase phi and intensity I. These are the characteristics of a wave. So there are different characteristics for particle and different characteristics for wave. Mass, velocity, momentum and energy are the characteristics of a particle. Wavelength, frequency, wave velocity, amplitude, phase and intensity are the characteristics of a wave. And if you come to the concept of de Broglie's hypothesis. So according to Planck and Einstein, the energy can be expressed as E is equal to h nu. And according to Einstein's mass energy equivalence, E can be represented as E is equals to mc square. These are the two representations which explains about energy E. And if you equate these two, h nu is equals to mc square and h c by lambda is equals to mc square, and here h by lambda can be written as mc and lambda is equal to h by mc, and this can be written as h by p because here h is Planck's constant, m is mass of the particle and c is nothing but velocity of light, and the multiplication of this mass and velocity can be represented as h by p, that can be written as lambda equal to h by p, where p is nothing but the momentum. And according to de Broglie's hypothesis, let us suppose that there is an electron and the charge of the electron is E, and this electron is moving with a velocity v and it has a mass m. The electron has mass m, charge E, and it is moving with a velocity v under a constant potential v. At that particular time, the wavelength which is associated with the particle of a wave can be represented as lambda is equals to h by mv, where v is nothing but the mechanical velocity of the particle. So lambda equal to h by mv and lambda is equal to h by p. And if suppose the energy of the electron in terms of the potential can be represented as E is equals to E into V. When the electron is under potential, some potential, then the energy of the electron can be represented as E is equal to E into V. And also we know that the kinetic energy of the electron is E is equals to half mv square. And equalating these two, we can write as EV is equal to half mv square. And here we can write EV is equals to half, multiply with m with both sides. MEV is equal to half m square v square. And this can be written as m square v square is equal to momentum p square by 2. So p square is equal to this 2 mev, and this p is equals to square root of 2 mev. This is the value of momentum p. So momentum p is equals to square root of 2 mev. So de Broglie's wavelength can be represented, can be notified as lambda is equal to h by p. H by p, that means that is equals to h by square root of 2 mev. See here, h is nothing but the Planck's constant, m is nothing but the mass of the electron, and E is the charge of the electron. And finally, we substitute all these constants in this value in the expression. We can write lambda is equals to 12.2 electron volts divided by square root of V. Thank you.